Hello everyone, welcome. In this particular video, we are going to learn how we can implement the k-means clustering algorithm using Orange. So to do that, first we are going to go to Options, click on Add-ons, and then here you can select this Educational tab, and then click on OK. Once you do that, this Educational tab appears on the side, and we can make use of it to learn the k-means algorithm. So first I'm going to go to Data, click on Paint Data, and this can be used to create your own data sets. On double clicking, you see that there is an option called as brush that is already selected. And now when you do a mouse click on the canvas, you can see that points are being generated. If you want to individually add points, you can make use of the put option. And right now I'm going to continue with the brush option and create 3 clusters. I would like to see how the k-means algorithm performs on this dataset. We're going to go to Educational and click on Interactive K-means and connect the two of them. Now interactive k-means is what we can use when we are learning how the k-means algorithm works, and in practice we are going to be making use of this k-means that is present in the unsupervised tab. Now when I double click interactive k-means, I see this window that is there on the right side, and here you can see these points are nothing but the original dataset that we had created. For this, these rectangles or squares that are present here are the initial cluster centroids. These are chosen randomly. Now the next step is to recompute the centroids. As you can see, most of the blue points are here, but the initial centroid that was chosen was this one. So we expect the centroid to move closer towards these points when we recompute the centroids. So if we recollect, the centroids are recomputed as taking the average of all the points that are present in that cluster. So when we do that, the blue rectangle moves closer to these points, whereas the red one moves closer to this. Whereas now we can see there are a few points that are colored green, but they are closer to the blue rectangle, so to say. So at this step, we reassign membership, in which we calculate the distance of each of the points from all the 3 cluster centers and assign it to that center it is closest to. So now we see this change happening. Now we can again click on recompute centroids, and we see that they have come more towards their center. Now at this point, it looks like all the points are assigned to the cluster that they seem to be the closest to. So when I click on reassign membership, we see no change happening. So at this point, we can say that the algorithm has converged. Now let us do more runs of this particular algorithm. So I'm going to click on randomize, and it is going to again start. But this time we are going to select one cluster here. Say I'll select another one here. This can be done by simply clicking on the square and dragging it to where you want to, and let the third one be here. I'm going to click on recompute centroids. It has moved slightly. Reassign membership. Again, recompute centroids. You can see some changes happening here. Okay. Yeah, so at this point, we don't see any more changes because right now all the points are assigned to the cluster center that they are closest to. Now, however, we see that these were the clusters that we saw in the previous run is kind of what we were looking for. But this time the algorithm has not given that to us. So this indicates two sort of issues with the k-means algorithm. One is that the solution that we get is dependent on the initial cluster centroids that we select. The second is that we might not always get the optimal clusters, so to say. The optimal clusters would have been if we were given 1, 2 and 3, but right now that is not what we are seeing. So how can we overcome this issue? So here you can see that these two cluster centroids are selected initially were very close to each other. So let me click on randomize again, and this time I'm going to select one cluster centroid to be here. Let me move the second one as far away from the other points as possible. And now the third one, I'm going to move it further away from the other two cluster centroids. Now once we do that, we can already see that there is some sort of a natural grouping that has formed. But we'll recompute centroids, reassign membership, recompute centroids. Okay, and at this point again the algorithm has converged. This time we seem to have done better. So this is one of the ways we can combat it. Likewise, Again, I'll click on randomize, and you can click on this run simulation to do the whole algorithm for you. And once this is done, it is going to stop here once there are no more changes. And again, I'm going to click on randomize, run simulation. Again, we see the results happening. This way we can run the algorithm multiple times, and at the end of it, we can take the average result that we had obtained. That is what cluster were each of these points assigned to. So this way we can combat the issue that was there, that was dependent on the initial cluster centroids that we had taken.